In this video, I will explain you electric field due to a dipole on an equatorial line. So equatorial line is nothing but a line perpendicular to axial line and passing through the center of the dipole. So this is the center of the dipole. Now we are going to take measurement of the point where we are finding the electric field from the center of the dipole. So this is the position. So now the position is at a distance of r away from the center of the dipole on an equatorial line. What is the net electric field at this position? To find electric field, I will keep +1 coulomb charge here. Now on +1 coulomb charge, which are the charges exerting force? Both minus and positive. Both the charges will give the force. But plus Q will be exerting a force in this direction. So this is the line connecting, right? So plus Q will be repelling in this direction. See, plus Q on +1 coulomb, it will be exerting a force in this direction. Now minus Q on this will be exerting a force in this direction. Okay. Now you can see a triangle here, right? This triangle is an isosceles triangle. You know what is the reason? See, we have in any triangle, in any line, if you are taking the midpoint and bringing a line that is passing through the midpoint and perpendicular to this, to any point, if you are connecting it from these two corners, these two edges, these two corners, this side and this side will be equal. Okay, whatever may be the total length, if you have drawn the line exactly perpendicular to this line and passing through the midpoint, then these two sides will be equal. Okay, so it's the same case, right? We have an axis here and through the midpoint we have drawn a perpendicular, and to one of the point we are connecting a line from minus Q and plus Q. So these two things will be equal. It's a basic triangle property. Okay. Now what will be the value of this? See, if this is R, if this is A, then that is root of R square plus A square. Why? This is perpendicular. Pythagoras triangle. And here also what will be the value? Root of R square plus A square. We need this length, right? Because this length is the distance between plus Q and +1 coulomb. This length is the distance in between minus Q and +1 coulomb. Okay. Now, if this angle is theta, then I can draw a parallel line here. This angle also will be theta. See, these two are parallel lines. Now see, you know this property, right? In a parallel line, if this angle is x, this angle also will be x. Similarly, if this angle is theta, this will also be theta. Now, anyway, we will try to get the value of electric field. This electric field due to positive charge will be equal to 1 by 4 pi epsilon 0 Q divided by this square. So square of square root will be R square plus A square, only this one. This is E plus. Now this one is E minus. So E minus is equal to 1 by 4 pi epsilon 0 Q divided by square. So square of square root. So that will be R square plus A square. I hope it is clear with you. See, we know the equation for electric field. What is that equation? Electric field is equal to 1 by 4 pi epsilon 0 Q by R square. Now here instead of R, we have root of R square plus A square. This distance we have to consider, right? Square of this root will be gone. So this one will be the square. So 1 by 4 pi epsilon 0 Q divided by R square. Same 1 by 4 pi epsilon 0 Q divided by square of this distance. So this root will be gone. Now these two electric field are the same, but they won't cancel each other. Why? these are in two different directions. So as they are same, we will do one thing. We will find its component in this direction. So this will be having a component in this direction. This will also be having a component in this direction. Now if this angle is theta, this angle also will be theta. Okay, now so this can be split into two components. One is this one and another one is this. So E plus, once again I will repeat, what is this? E plus Q. So this I am going to split into two component. One is this one and another one is this one. So E plus Q has two components. What is that? One is perpendicular component, perpendicular. So this component, perpendicular component of E plus Q, and another one is horizontal, this one, horizontal component of E plus Q, Now what will be the perpendicular component? This one is the perpendicular component, right? So if this is taken into two directions, we know that if this one is E and if this is theta, this will be E cos theta and this will be E sin theta. Basic trigonometry. So the one which is having theta will be E cos theta component, the one which is not having theta will be E sin theta. So E plus Q I am going to split into this, it has no theta, so this will be E plus Q sin theta and this will be E plus Q cos theta. So perpendicular component will be E plus Q cos theta, sin theta. Here horizontal component will be E plus Q cos theta. We know that E plus Q and E minus Q is the same. See, this is E plus Q, this is E minus Q. Does it have any difference? No, magnitude is the same, only direction is different. Okay, now E minus Q has two components. One is perpendicular component and parallel component. Now this is E minus Q. Perpendicular component is this one, parallel component is this one. So what will be the parallel component? It has theta in it, right? So this will be E minus Q cos theta, this one. So that is parallel component, E minus Q cos theta. And what will be the perpendicular component? Perpendicular component of this will be this, that is E plus Q sin theta. Now E plus Q and E minus Q, this will be E minus Q. We know that E plus Q and E minus Q is the same, magnitude is same. Now see, E plus Q sin theta you have here, E minus Q sin theta you have here. So E plus Q sin theta is nothing but this, and the same value you have as a component of E minus Q in this direction. What is that? E minus Q sin theta. So you have E plus Q sin theta upward and E minus Q sin theta downward. As E plus Q and E minus Q are same, they will cancel each other. So these two will cancel. E plus Q sin theta and E minus Q will cancel each other. What is the reason? Since equal and opposite. Now what will be the case of E plus Q cos theta and E minus Q cos theta? This is E plus Q cos theta, this one. Now E minus Q cos theta is this. So these E plus Q cos theta and E minus Q cos theta will be added up. Both are in the same direction. So net electric field. Net electric field is equal to E plus Q cos theta plus E minus Q cos theta. So E plus Q cos theta plus E minus Q cos theta. See, E plus Q means electric field due to plus Q and electric field due to minus Q. We know E plus Q, you can substitute the value. This is E plus Q and this is E minus Q. So substitute it. substitute and give here. So E plus Q is, this is E plus Q, 1 by 4 pi epsilon 0 Q divided by R square plus A square cos theta plus 1 by 4 pi epsilon 0. What is E minus Q? This one, same value, Q by R square plus A square into cos theta. So it's the same value plus same value, that is twice the same value. So 2 into 1 by 4 pi epsilon 0 Q cos theta divided by R square plus A square. Now we will substitute the value of cos theta. From here, what is cos theta? From this, cos theta is equal to adjacent divided by hypotenuse. Adjacent divided by root of R square plus A square. Okay, so this will be 2 into 1 by 4 pi epsilon 0 into A divided by R square plus A square into cos theta is A divided by A square R square plus A square. What is root means 1 by 2. So R square plus A square the power 1 into R square plus A square the power 1 by 2. What is A power m into A power n? That will be A power m plus n. So similarly this will be 1 plus 1 by 2. The value will be 3 by 2. So that is equal to, on the numerator you have 2aq divided by 4 pi epsilon 0 into R square plus A square the whole power 3 by 2. Very important relation this one is. And in the similar way we have done an approximation with previous case. We will bring the equation here. When R is very greater than A, we can consider A as 0 here, not here. Okay, because this, see, square of a small value will be very small. For example, 0.2 square is 0.04. So this will go close to 0, but it's a small value here. Anyway, for 2aq I am going to consider it as dipole moment. So don't cancel this A, only cancel this A. So 2aq is nothing but dipole moment. So electric field will be is equal to, this one is dipole moment, and 4 pi epsilon 0. A can be considered as 0. So R square the whole power 3 by 2. So square and 2 will cancel. So this will be R cube. So I will rewrite it as, I will take 1 by 4 pi epsilon 0 as a constant is equal to, so into, 1 by 4 pi epsilon 0 P by R cube. Very important relation this one is, very important. 1 by 4 pi epsilon 0 P by R cube. Now what is the direction here? We have learned that E plus Q cos theta and E minus Q cos theta is in this direction. Now what is the direction of dipole moment? Minus Q to plus Q. And here electric field is in this direction. So that is just the opposite to electric field. Sorry, dipole moment. So electric field here is opposite to the direction of dipole moment. So you have to keep a minus sign here. Then only this will be in a vector form. Okay. Now compare both the equation. So it's only one difference. Only one difference. See here in this case electric field. So this is on equatorial line. Electric field is equal to minus P 1 by 4 pi epsilon 0 into minus P divided by R cube. Okay, so it is 1P divided by R cube and the direction is opposite to the direction of dipole moment. And on axial line, electric field is equal to 1 by 4 pi epsilon 0 2P divided by R cube. And here is along the direction of dipole moment and that is 2p here, it is 1p, and the direction is opposite. So direction is different, and even the multiplier of coefficient of p is also different. So compare and learn. These two are very, very important. Okay, thank you.